Okay, so we are doing chapter 15, number 11, and if you look into your book, you can find that the givens of this problem are that it is a 0.500 kilogram object, and also the force constant is 8.00 newton meters, and that the amplitude is 10.0 centimeters. So when we look at what we need to find, A is we need to find the max value of speed and acceleration. B, we need to find the speed and acceleration when the object is 6 centimeters from the equilibrium position. And then C, we need to find the time interval required from x equals 0 to x equals 8 centimeters. 8 centimeters. So starting off for A, we're going to use the formula of omega equals the square root of k over m. So then we're going to take that, and k is going to be our force constant. So our k is equal to the 8.00 newton meters. And then that is divided by m, which is our 0.5 kilogram object. So we take that, and then you're going to divide, and that's going to equal 4.00 seconds to the negative 1. Is that into the formula of x equals 10.0 sine of 4.00, which we just found, times t centimeters. So this is going to help find our position. And then from that we can find that v equals 40.0 cosine of 4.00 t centimeters per second. So by solving this, the v 40 cosine 4 times t, we get our v max, which is going to be 40.0 centimeters per second. And then we need to find our max acceleration. So A equals negative 160 sine of 4.00 t centimeters per second squared. And we solve this, and we get A is equal to 160 centimeters per second squared. And that's going to be our A max. Okay, so now we're done with A. Okay, so V, formula, T equals 1 over 4.00. This is our 4 that we solved for in A. Sine inverse of x over 10.0. And our 10 is our amplitude. So then we are going to use, so x equals 6.00 centimeters, which is the given of the speed acceleration when object is 6.00 centimeters from the equilibrium position. And then our t equals 0.161 seconds. So then we are solving for v. So at x equals 6, which was the given, we plug that into here, and we find that t equals 0.161 seconds. So then we're finding v, and v equals 40.0 cosine of our 4.00 times our time 0.161. And that gets us to equal 32.0 centimeters per second. And then to find A, it's going to be negative 160 sine 4.00 times 0.161, which is our time again. And that's going to equal negative 96.0 centimeters per second squared. So that is all of B. Now moving on to C, where we are finding the time interval required from x equals 0 to x equals 8 centimeters. We're going to use the formula T equals 1 over 4.00 sine inverse of x over 10. That when x equals 0 and t equals 0, and then we're also going to plug in for when x equals 8.00 centimeters and t equals 0.232 seconds. So we find the delta t, which equals 2.232 seconds, because the difference between the 0 and the 2.32 seconds, which is our answer.